Morning, everybody. Thank you all for being so patient and for attending this session this morning. I'm Hines. I'm the moderator. I'm the director of the Smithsonian Environmental Research Center. We're located out on Chesapeake Bay. And the Smithsonian is very pleased to host this session today on people who use the planet for lots of different ecosystem services. We're learning to manage our activities more wisely, and there are many optimistic, positive stories about that, whether it be sharing our shipping lanes with recovering numbers of whales in the ocean, or learning how to coexist with wildlife in complicated urban and agricultural lands, or restoring forest to whole watersheds. Wildlife, people, and functioning landscapes can and do coexist very effectively on the planet, and we need more examples of that and to use and learn from those success stories. We'll have, even though we're starting late, we'll continue the session as planned with a full hour and 15 minutes, with 15 minutes comprised of 12 minutes for speaking and 3 minutes for transition and brief questions, if we can stay on schedule, which we will. And I will, that will be my job to make sure that we do. Without further ado, let's get started. And our first speaker today for this session is Tremaine Gregory. She's a conservation biologist at the Smithsonian Conservation Biology Institute in the Center for Conservation and Sustainability. Much of her work is based in tropical forests of South America. So, Tremaine.
Good morning, everyone. Thank you for being here, and thanks for waiting out the change of schedule. So today I would like you to first begin by imagining that this is your house. If you can see, there's a small house there on that hill. And you wake up one morning to find that a giant crevasse has formed outside your doorstep. And this crevasse crosses your path to town. And town is where you do your grocery shopping. It's where you buy your clothing, where you find all of your resources for your daily life. What are you going to do? You can't get there anymore. Now imagine you're this mother howler monkey. You have your very precious cargo on your back. You're walking along in the morning, and suddenly you see that this has formed at your front doorstep. This is a pipeline being built through your forest. And, well, you don't really like going down to the ground all that much, so how are you going to get to the other side? If you were this jaguar, you might say, oh, wow, a pipeline, that looks like a nice path through the forest. I can kind of saunter down, maybe sneak up on some tasty little treats as I go. I think I kind of like this open pathway. But if you were that mother howler monkey, or if you were this capuchin monkey, again, you might not be so excited about this open clearing in the forest. You can see this capuchin monkey is standing on his back legs. He's really uncertain. Coming down on the ground is kind of a dangerous prospect for an arboreal mammal, or an animal that's used to living in the treetops. So let's back up for a minute and talk about how a mother howler monkey could end up with a pipeline at her front doorstep. This is a map of Peru. The colorful background illustrates the diversity of mammals. The similar pattern is true for birds and amphibians, but I'm just focusing on mammals today. You can see the black polygons are fossil fuel blocks that are under contract with the Peruvian government. The purple dots are exploratory wells where drilling was done for fossil fuels. These are just the onshore concessions. I didn't include the offshore concessions. But as you can see, there is very high overlap between these concessions and these exploratory areas, and very diverse areas for mammals. So you can see why this could be a problem for those mammals. Now, when a company takes responsibility for one of these concessions, when they go under contract with the government, it doesn't mean that they're going to clear cut them by any means. But it definitely means that they will engage in a lot of potentially impactful activities. like seismic exploration. They can do exploratory drilling, as I explained, in some of those sites. And if they find fossil fuels, they may go ahead and build a pipeline. So here is another example of a pipeline. And I want you to look at this for a second and think about, if you were moving through the treetops, what are you going to do now? You've got to come down to the ground in order to get to the other side. When pipelines like this are built, they don't necessarily take into account what's going on with the forest canopy. They're focusing on getting the pipeline in the right location, clearing that clearing, making sure their vehicles can pass through and that the pipeline can be laid. But what if we talked to a company about a solution? What if we said, can you leave some places where arboreal mammals could continue to cross? Could you leave places where the branches of some pretty large trees connect with the branches of large trees on the other side, where the branches interlace and animals could keep crossing? We could call this a treetop bridge even, maybe a canopy bridge. So we found a company that was willing to do a project like this with us at the Smithsonian Conservation Biology Institute. We partnered with this company. This was a company willing to understand how to reduce their impacts, investigating different methods for impact reduction. And they were excited about this canopy bridge project, about leaving crossing places. So we worked with them for many months on end. We exchanged knowledge about engineering. I learned a lot about different aspects of building a pipeline, and we in turn taught them about natural history of arboreal mammals and other animals. And we looked for places where, when that pipeline was finished being built, this was actually before the pipeline was built, we looked for places where those branches could interconnect and animals could potentially cross from the other side, from one side to the other. In this picture, I'm putting up a sign with one of the people that's working on building the pipeline that says, "Do not cut. Do not cut this tree. We're hoping that it will form a bridge later." Of course, as we were choosing these locations, we couldn't necessarily tell if the branches would connect. But as they became exposed, we could see that. So here you can see a series of 3 machines called side booms lowering this natural gas pipeline into a trench. This pipeline is 16 inches in diameter. It will carry natural gas from the Peruvian Amazon up over the Andes and over to the Pacific, where the natural gas may be loaded on tankers and transported in other ways. So this pipeline is lowered into this trench. The trench is about 2 meters deep. It's buried, and then it's covered over. So when they were building this pipeline, again, we asked them to preserve certain trees that will leave these canopies, these natural canopy bridges. When all was said and done, we had 13 bridges, and we thought, wow, this is great. Okay, now what do we do next? Well, I guess we need to see if animals are actually going to use the bridges. Otherwise, why should the company go to so much trouble to leave them? So we thought, okay, should we put some radio collars on some monkeys? What should we do? Well, maybe we need to get up into those bridges. Maybe that'll be a little easier than doing the radio collars. Or, I don't know, would it? Who knows? So we decided to learn how to climb those trees. This is me with my colleague, Farah Carrasco. We took a Christmas trip to Panama a couple years ago, and we learned how to climb canopy trees. This is a pretty exciting prospect for me, a primatologist who'd never been up into the canopy and never really seen it for myself, seen the world that these animals I'd always stared at from the ground, what kind of world they lived in. And after getting all this great training, well, up we went into the canopy. So here I am, just like that, it was one day to the next. No. So actually on the ground, you can see the pipeline clearing passing through the forest. This is a bridge, obviously. And actually that one of those people on the ground is like 6'6" or so. So you can see I was up pretty high. I was at about 100 feet here. And I was going up to put a motion-sensitive camera or a camera trap in the canopy. And camera traps, you've probably heard a lot about them by now. They can sense the movement and the body heat of an animal as it passes in front of them, and they take basically an animal selfie. So This way we could monitor all those bridges and every connection within a bridge to see if animals were actually using them. But of course, we also wanted to know if they'd be just as willing to cross on the ground. So we put camera traps on the ground also. Here's an example of a camera trap in a bridge connection. And this is the path that an animal would need to take in order to cross over that bridge connection. And here is the outcome. So that's a group of night monkeys crossing over that bridge. And here is the series of images that I kind of pasted together, and you can see the group crossing here. And that is the wonderful male monkey who carries that heavy baby all over the place, much like my husband is nice enough to do with my heavy baby. So in this next series, this is an emperor tamarin. He's crossing along that bridge. Here's a saddleback tamarin who's a little nervous about the camera. And here's a group of saki monkeys, my personal favorite. They don't really look like monkeys, but indeed they are. They're very fluffy monkeys. And this is a bunch of different individuals. I just pulled the individual pictures of the members of this capuchin monkey group. You can see some of them have yellow dusting on their faces. They've been feeding on the pollen nectar of flowers with a little bit of pollen left on their faces. Here's a mother tamandua who's walking along with her gigantic baby on her back. She also seems to be pregnant, so this mother is working overtime, that's for sure. And here is a kinkajou. He's a little curious about the camera trap too. He's just come over this bridge. And a group of porcupines. These guys were my nemesis because they like to gnaw on my cameras. As you can see, the camera moving back and forth. Sometimes I would find them all the way open and flooded with water after the porcupines had their fun with the camera. And then finally, a sloth slowly crossing the bridge. So, getting to our question. If we gave the animals an option of crossing through these canopy bridges or crossing on the ground, which would they prefer? Well, over a year of monitoring those 13 bridges, we found that 25 arboreal mammal species use the bridges. That was a pretty exciting number for us. Every time we checked the cameras, it was like Christmas. We'd see something new. On the ground, we saw only 6 of those 25 arboreal mammal species. There were other terrestrial mammals. There were jaguars and everything else, but of course a jaguar is not going to cross up in the canopy. So only 6 of those arboreal mammals were found on the ground. With regard to the number of crossings that we saw, over that year, we actually saw over 3,000 crossings in our over 1 million camera trap images that we went through one by one. And so that was pretty exciting, 3,000 crossings. How about on the ground? Just 16 crossings on the ground by arboreal mammals. So what do you think? It seems like they're pretty popular, those bridges. And what was really cool is that when we started to look at the individual animals that crossed those bridges, we counted, conservatively actually, over 150 different individual animals crossing the bridges in that year. So this project, I think, is a really optimistic story about partnering with a corporation that's interested in doing things in a better way. And we're excited to report that there are a number of other projects, pipeline projects in the Peruvian Amazon right now that are incorporating canopy bridges into their pipeline designs. And the Peruvian government has been very excited about our results, and we're optimistic that they will make canopy bridges part of legislation in all pipelines that are built in the Peruvian Amazon. So with that, I'd like to take you back to the first image and ask you if you have, and tell you, I guess, if you have a crevasse in your front yard, well, maybe consider building a bridge. And finally, I just want to give a shout out to Evan Keeling, who made these comics about our project. He's got a booth out in the atrium area, and it's a great way to share your project with different groups of people. Thank you very much.
We have time for one question for Tremaine and maybe some time afterwards. If you have a question, please use the microphones. There's two in the main aisle here. Anybody got one question? Okay. Thank you. Our next speaker is Roland Case. Roland is a wildlife biologist at the North Carolina Museum of Natural Sciences and North Carolina State University, as well as a research associate at the Smithsonian Tropical Research Institute. His diverse interests include using camera traps also and other ways to understand mammalian predators interacting with humans. Roland.
Great, thank you very much. Thanks everyone for coming. So today I'm going to be talking about the return of wildlife to urban America. And cities today have quite a surprising amount of wildlife in them, but it hasn't always been that way. Cities in the United States have not been wildlife friendly typically. This is a seal from the town of Albany in 1752. It's got a beaver on it. And this wasn't because there were so many beavers in Albany in 752. It was because that's where all the skins moved through for the fur trade. And really, our country was founded on fur. The exploration into the different parts of our country in its early days and leading into the 17 and 1800s was a lot about harvesting wildlife. Here you can see this is from 1920 in upstate New York, and this was not done sustainably initially. It was done without rules, and people were just trying to make as much money as they could. And these, in particular, there's an animal called the fisher that was a favorite. The fisher is, it's in the weasel family. It's a pretty big weasel. It's about the size of a house cat, 5 or 10 pounds. And they had really nice fur, and because they were big, you could make you could make jackets out of them, hats, etc. So in the 1920s, for example, a good fisher pelt could be worth as much as $345 in 1920s dollars, which would be thousands of dollars today. So if you were a poor farmer and you saw fisher tracks running through your land, you went out and tried to get that fisher, and there was no regulation on it. So you can imagine Albany in 1952 had no fishers living in the town border. There were probably no fur bearers of any kind living there at all. And the result of this was that fishers and other wildlife in North America declined across the continent. This shows you the change in the distribution of fishers leading up to about 1930, the low point of the distribution when they were only in in the light green area. So they disappeared from almost all of the lower 48 states, surviving in some of the wilderness areas that the trappers couldn't quite get to. So it wasn't that they were prevented from getting there by any rules or regulations, just that it was hard to get into these wilderness areas. And studies of the fishers showed that, at the time and leading up, into the rest of the 1900s, that they required closed canopy forests and that they were really kind of an old growth specialist. This says they were habitat specialists that require mature forest. This was, kind of the textbook of fishers when I grew up and when I was in college learning about the mammals of North America. So you can imagine my surprise when in 2002, I got this camera trap picture of a fisher in suburban Albany, New York, where there hadn't been fishers for hundreds of years. And here was a photograph. So I thought, this is really crazy. This must be some fisher that's moving, from the Adirondacks to the Catskill Mountains or something, and is just passing through town. Because this is what suburban Albany looked like in 2002. And this is actually right around where we got the photograph. You can see the neighborhoods, there's Crossgates Mall, there's a university downtown, and there's these little patches of forest in between there, and that's where we got this camera trap picture. So surely this wasn't actually a resident fisher. And I started looking into fishers and learning more about fishers, and in fact, fishers had made a remarkable recovery. This shows you how they had expanded their range back out into new areas through protection of having regulated hunting. So initially, hunting and trapping was eliminated in the 1930s, and then their populations recovered. They started filling the wilderness areas. They started moving into the rural areas. And then some trapping was allowed, but it was tightly regulated in a sustainable way. But really, did we really have suburban fishers? So to really find out, what were these animals doing and were they really there? My student Scott LaPointe and I did a study using some high-resolution tracking collars. By the way, she's tranquilized or she'd chew his hand off. They are fierce predators. Fishers are one of the only animals that can regularly kill porcupines. They are very aggressive to rodents, for example. And we found when we ran camera traps in the suburban forests and also out in the state park outside of town, which is a much more wild area, we actually got way more pictures in the urban area. There was tons of fisher activity in these forests. So our GPS tracking data showed us exactly where these animals were going. We got some really nice tracks showing how they were using the area. In this case, the Mohawk River was frozen, and so it was moving back and forth over an open river. There's no closed canopy. If you look up on the left, there's the Schenectady Airport. The animal cuts right across this open airport area. And if you look at some of these restrictions where it crosses that main road, we thought, why is he going to exactly the same place to cross the road? And so we put a camera trap there, and here you can see this little half-filled crappy drainage culvert that is a tunnel that these weasels love tunnels. And so he's going through this tunnel back and forth. This is Leroy, the fisher. You can see he's got his tracking collar on. And so this is how they're basically colonizing the city using this network of tubes. And they're using all sorts of what I call unclaimed habitats at night, right? No one's in the golf course at night except the rabbits and the fishers. And so here you can see all these pink points are GPS locations of a fisher. This is an amazing animal. This is a 6-lane highway, Route 87 and Central Avenue going this way. And he's gone into the little clover leaf of forest that happens to be left. And he's hunting animals. And he's using culverts to cross underneath those access ramps. And then he goes over here, right here, and goes under another culvert to hunt that little tiny strip. And I went there right after we downloaded the data. I was like, what is going on? And I went there, and there was a little cover of snow, and there were so many rabbit tracks in that little strip of forest. This is the kind of place you might expect to see a red-tailed hawk during the day. Fishers are going there at night. Occasionally, they'll cut through neighborhoods. Here you can see a fisher track running across someone's front yard. They're using a variety of different rest sites. They're quite flexible. They use brush piles behind people's houses, garbage piles, holes in the ground, and our favorite was the squirrel nests, these leafy squirrel nests that we called fisher bed and breakfast. Because indeed, they were eating a lot of gray squirrels. So why move to the burbs? It's really good eating. There's tons of gray squirrels there. There's lots of rabbits. So this little pie chart shows what we found them eating. A lot of gray squirrels, a lot of rabbits. They weren't killing deer, but if they could find a deer in the winter, it'd be frozen. They chew on it all winter long. And I think part of this is that prey species colonize the suburbs first, escaping from their predators. This is just a little fun little gif of a chipmunk and a bunny dancing around someone's yard. They went into suburbia first to get away from the predators. And eventually, the predators are moving in, following them in. But fishers aren't the only backyard predator. I want to talk a little bit in the second half of this talk about coyotes. And coyotes are a different story. Now, coyotes have also expanded their range. But unlike the fishers that were reclaiming old territory, coyotes are moving into new territory. And they're doing this after they've actually hybridized, in many cases, with dogs and or wolves. So the coyotes that are now in the eastern United States, they're still mostly coyote. They're 80-90% coyote, but they do have a smattering of dog and wolf genes that seems to have helped them grow relatively, evolve to be larger animals. And they did the same thing the fishers did, in that first they colonized the wild areas, then they moved into the rural areas, and now they're starting to enter the cities. And I love this graphic. This is from the Walrus magazine, a nice artwork sort of showing how coyotes are starting to move into the cities. But unlike fishers, coyotes never got a break. This is a dead coyote in the back of some hunter's pickup outside of New York with their hounds. Hunters in rural areas hunt coyotes mercilessly. I went to one tournament where they killed 170 in one weekend. They hunt them in all sorts of different ways. Coyotes never got a break. I mean, in some ways, they're an invasive species. I mean, they're sort of recolonizing the area that the wolves are extinct from. But they have expanded despite this intense hunting and trapping pressure. And if we think about why would they move to the suburbs, there's the same abundance of rabbits, which they like to eat. But there's also a lot less hunting pressure in the suburbs. This graph shows the decline in the human-caused mortality in carnivores as you move from wild areas into cities. people don't hunt. You can't shoot a gun in the city. You can't run traps because you might catch a dog or a cat or a kid. And so if these animals can find their way into the city, they're going to have a lot less. You can see the mortality of some of these carnivores in rural areas caused by humans. 60, 80, 100% of the deaths are caused by people. So in North America, there's quite a lot of hunting pressure, and they can escape that if they move to the cities. The other interesting thing about coyotes is the difference between eastern and western coyotes. Western cities have had coyotes as long as they've been cities. Coyotes have had a longer time to adapt and evolve into urban specialists. And they are more highly adapted, and they're actually starting to cause some trouble. This headline on this newspaper from the Los Angeles Times says, "Coyote enters home and snatches dog near sleeping baby." It went in through an open window to grab a chihuahua. They really don't seem to like chihuahuas. But they are killing pets, and they are right in neighborhoods. I saw another news item where it scaled a 12-foot cement wall and killed someone's dog, a little sort of small lap dog in their backyard. This is problematic. And in the East Coast, we don't have nearly these types of problems, and we don't know if we will. Or this is a headline from D.C. that says coyote-wolf hybrids have invaded Washington. And so they're still kind of novel, but there are certainly, we ran camera traps in Rock Creek Park recently and had 123 coyote pictures. We only had one cat picture, right? There's a connection there. This is a picture of a California coyote carrying a cat through an underpass. And generally, in our research, we found that cats are rare where coyotes roam. So what can we do if we didn't want them to be here? One thing we can do to reduce the risk is don't feed them. This is some coyotes right in someone's backyard. They've got their nose to the ground. They're eating some food that might have been let out for cats, might have been let out for coyotes or raccoons, who knows. But we don't want coyotes coming into house yards looking for food, because this is what is going to lead into more conflict. But past this, there's not a lot else we can do. So we should enjoy them. This is a beautiful black coyote from eastern North Carolina, probably has some dog genes mixed in. You can see his friend back there in the background with his eyes shining. These are beautiful animals, and we can't, like I said, we can't start trapping them. We can't start hunting them. We need to realize that these animals are here, and they're living in our urban areas, and they're not going away. And that there's a good side of predators. Think about, how many people have gotten their shoes all messed up from all the geese poop in the variety of urban parks, right? The balance of nature has gone askew by all these prey species moving into suburbia, doing quite well, and not having predators. And so the return of coyotes and fishers and other predators, it's not just coyotes and fishers. We have mountain lions in Colorado and California. We have recovery of wolves, not necessarily in cities yet, but wolves are recovering around the Great Lakes. There are many dozens of wolf packs in Germany. There's a wolf pack in Denmark now. The predators are moving back into cities. There's some remarkable footage recently of leopards moving into cities in India. So these species are adapting. Evolution is acting. The animals that survive and breed and pass their genes on are the ones that have the next generation. So what I've really told you today is two evolution tales. One about the fisher, where if we give them a chance, they can adapt and survive, right? We protected a population, let them build their population back up and have a lot of variation. Natural selection and evolution act on this variation, selecting the ones that can survive in the habitat. And this shows that we can make a difference. If we hadn't have protected the species, the fisher would have been gone for sure. Okay? And this is what we can do for other species that are suffering under unregulated persecution. But then there are other species like the coyote, where it doesn't really matter what we do for the coyote. They are so adaptable and so flexible and so smart, and that they are making us realize that we are part of nature. When we're in cities, there are predators there, and we need to think about what we do, whether we let our cats outdoors, whether we let our toddlers play unattended in the backyard. They don't attack adult humans, but little kids could potentially be at risk, and there's really nothing we can do about it. And so I think we need to, recognize that we are part of nature. So I just want to end a little bit with some speculation about how far can evolution go. And this picture came to me from Cape Cod. It's a fisher on the beach. And if you think about fishers, as I learned about, were old growth specialists that needed overhead forest canopy, right? There isn't a tree in a long way from this. So I thought, well, this is the epitome. This is as far as it's going to go. And then I got this picture from the Bronx. of a fissure. A police officer took this picture in 2014, and I thought, if these fissures can colonize the tubes and tunnels in New York and start eating rats, we could have a whole new species, a whole new specialist urban predator. And so I'll end with that. Thank you very much.
Again, one question. Anybody? Please use the microphone.
I have a question. Could you elaborate more on like the emergence of like these coyote wolf hybrids? Because I heard that they can actually produce fertile offspring. Is that true?
Yeah, so sure. The coyote and the wolf are closely related to each other, along with the dog. They're all in the same genus, Canis, and they generally don't like to breed with each other. And it's not happening actively now. When it happens is when one species is brought to a very low population size, and they can't find another of their own species to breed with. So, for example, the way we think it happened with eastern coyotes is in the Great Lakes area. The wolves were really dwindling 100 years ago or so. There was probably some female wolf, based on the genetics, it was a female wolf that couldn't find another male wolf to breed with, took the next best thing she could get, sort of, right? And so that produced an F1 hybrid that was half coyote and half wolf. Those animals, it happened more than once, crossed back into the wolves and back into the coyote, so you had these animals that were mostly coyote with a little bit of wolf. That animal migrated, was the animal, there were all these different variations. That's the one that moved east. That's the one that rapidly colonized new area because it was well adapted to this new environment. And I think as they were moving east, there was some coyote with a little bit of wolf that was at the leading edge, couldn't find any other coyotes to breed with, and there would have been feral dogs running around, and so they hybridized at that point in time. So that hybridization is more recent according to the genetics. And now they don't. They don't hybridize with dogs or wolves because they are, there's plenty of coyotes around.
Thanks very much. Very interesting. We're going to change gears now, but we'll come back to wolves in a few minutes. The next speaker is Nick Pyenson, and he's a curator of fossil mammals, marine mammals at the Smithsonian National Museum of Natural History. And in addition to his research on vertebrates evolving and reinvading the ocean, Roland is tracking, Nick is tracking the recovery of whales since they're near extinction.
Great. Thanks, Doc. I'm happy to be here. So there's a lot that you can talk about success stories with whales, and gray whales come to mind as one of the great success stories, and I will tell you more about that in a second. But the point of my talk is to step outside the boundaries of just sort of current time, seasonal time, and talk a bit about deep time and why that matters for a success story like gray whales. My day job is based at a place right across the street, a block away at the Natural History Museum. You can walk in right off the street into the Ocean Hall and see this, a beautiful display about the evolutionary history of whales, how they once had land ancestors. And I'm going to spoil something for people in the front audience and a lot of other people. You can see a cast here, painted cast, of a fossil gray whale jawbone. I'm going to talk a bit about this, but one thing I won't tell you is where it's from. I'm going to reveal that later in the talk. So you can go upstairs from the Ocean Hall into the Osteology Hall. And I really encourage you to do this because this is a hall unlike any of the others. It's been unchanged since about the 1960s. You can see that in the typography and a bit of the exhibit structure. But if you look up, you will see the skeleton of a gray whale. And that is not just any gray whale. That is a gray whale from the Western Pacific. We don't have very many specimens from this part of the Pacific. Gray whales live in the North Pacific today. But that specimen was actually collected by Roy Chapman Andrews. Now, for those not familiar with Roy Chapman Andrews, he was kind of the prototype for Indiana Jones. He was a curator at the American Museum of Natural History in New York and did his PhD on whales before he went off to Mongolia looking for human origins and lo and behold found dinosaur eggs. And that's what kind of that's why we remember Roy Chapman Andrews predominantly in the media. But he did write this book called Whale Hunting with Camera and Gun. And we have to realize that this is 100 years ago, 1916, a very different time, kind of more of a Rooseveltian ethic to conservation. Go out and bag the specimen, bring it back to the museum, and then we can talk about conservation. Now, that's it. I don't want to get into that philosophy, but that's really the view at the time. Now, what he did was also document all this with a camera. And here we have one of these Korean gray whales from the Western Pacific on a flensing platform being processed. That specimen in the Osteology Hall might actually be this one in the picture. I haven't actually tracked and united that documentation. But this is what we're looking at with the history of gray whales, is a massive exploitation that occurred at the end of the 19th century into the early 20th century. This is 1916. So by this time, most of the gray whale population in the North Pacific had been depleted by human hunting. A lot of this happened at one of their specific places called Scammons Lagoon. This is in Baja, California. Gray whales undertake this massive migration from Baja to Alaska every year, breed down in Baja in Mexico, migrate some 6,000 to 10,000 miles up to the Bering and Chukchi Seas where they feed. So we'll get back to that in case it's not clear. Gray whales now, I think everybody realizes, have recovered from massive exploitation. Here we are in 2017. Gray whales now in the North Pacific hover around 26,000, 28,000 individuals, give or take. You probably know about them if you've seen these Wyland murals all across anywhere on the West Coast. They're beloved icons of natural history on the West Coast. And if you're lucky enough to go down to Scammons Lagoon today, there is no whaling going on down there. There's whale watching. You can go out, and marine mammal laws are different in Mexico than they are in the United States. You can actually pet gray whales if you want to. So this is where it gets interesting when we look at the science about where gray whales are today. Paper published about 10 years ago out of Steve Palumbi's lab. Steve is here today, he's walking around. He and one of his postdocs at the time, Liz Alter, did a study looking at DNA in gray whales and wanted to know what DNA diversity was like before human hunting. We know the signal of human hunting. We can time that pretty closely. How many whales were there before whaling? The short answer is a lot, but we just don't know how many. And the question about how many magnitudes more gray whales there were is really important for management today. If we want to know how many gray whales should be out there in the oceans, the United States Marine Mammal Protection Act has exclusions for hunting, so there are some indigenous tribes that do hunt gray whales. And also gray whales are the victims of shipping lanes, of ghost nets, there's entanglements, there's strandings. So we actually want to know, really, what is our baseline expectation for gray whales before humans? Now, I got interested in this because I'm interested in their fossil record. And I knew that there are fossil gray whales all throughout the North Pacific. And what I have here on the right are this kind of jagsawed pattern through time, going up and down, up and down. This is sea level change over the last 3 million years or so. And we have gray whale fossils that predate the onset of the ice ages, sea level rise and fall. So if we look at their migration plot going from Baja to Alaska, anybody who realizes something about deep time recognizes that when you drop sea level, you lose that destination that they want to go to in the top left corner. The Bering and Chukchi Seas, at many times, over 20 times, throughout the last 2.5 to 3 million years, was an emergent platform. There's going to be no food in dry land for a gray whale to feed on. Also, if you have ice sheets going all the way down to Seattle, to say nothing about ice sheets covering Boston, New York, and all the way down here to DC, where are gray whales going during glacial maxima? So I looked at this in some detail, and I think the answer has a lot to do not with a picture like this. Gray whales are notably ice tolerant. If you remember about 25, 30 years ago, gray whales were stuck up in Alaska, and there was this human intervention that united both Russians and Americans, and this shared cause for concern for about a dozen gray whales. They are just fine in the ice pack. So it's not about tolerance of ice. It has more to do with their flexibility. Gray whales can actually feed on a variety of prey resources. And we know that there are some today that don't actually migrate. They hang out around Vancouver Island and off of Washington State, and aren't a part of the 99% that migrate from Baja to Alaska. So that flexibility, I think, is important, but I'm going to shift for a second and tell you this jawbone, which I have a picture of right here, is not from the Pacific at all. This is from the Atlantic Ocean. This jawbone was actually found in Gray's Reef in the National Marine, JY Reef, which is part of Gray's Reef National Marine Fisheries Sanctuaries, which is right off the coast of Georgia, here on the Atlantic coast. So it turns out that gray whales have actually been in the Atlantic basin for far longer than they've been in the Pacific basin. We just don't have them here today. Why they went extinct some 300 to 400 years ago, we don't know. It doesn't have anything to do with Yankee whaling, but we do find their fossils. And so I have colleagues here from the University of Georgia who were doing something else on a closed reef and discovered not just one, but two different jawbones right there on JY Reef. You can now see what that looks like here. It has all the diagnostic features of a gray whale. That is to say, it looks nothing like any other baleen whale that we know of. This jawbone is actually relatively small for a gray whale, and as is the second one that they found. These are juvenile specimens that are found off the coast of Georgia, and we know that they're about 10,000 years difference in age. This one here is about 30,000 years old. The other one is about 20,000 years old. This is an ice age gray whale here off the Atlantic coast. And so there's a whole hidden story to gray whales actually on the Atlantic seaboard. And what that's important here, because you can see on some parts of this jagged pattern through time of sea level change, sea level is actually much higher than it is today. And think about where this is going in Anthropocene Earth. We are heading towards these potential realities of having very high sea levels. If you have high sea levels, then maybe going through an ice-free Northwest Passage isn't as difficult. So, stepping back once more before we go forward in time, Scammon, 1874, he drew this picture of gray whales up in Alaska because he was not just a whaling captain who did participate in the slaughter of gray whales, he was also a naturalist at the end of the 19th century, and he was the first one to document living gray whales. But he wasn't the first one to name them. The first person to do so was a scientist in Sweden who found a fossil gray whale skeleton and gave it its scientific name that we use today, Escherichthus robustus. So there's this hidden history of gray whales in the Atlantic. And this is where it gets even more surprising. I remember being on the Marine Mammal Listserv in 2012 when this picture cropped up. It was sent by an Israeli scientist, and he said, "I think we saw a gray whale off the coast of Israel in the Mediterranean. Please tell me I'm wrong." And that diagnostic feature, along with all the other photos that he sent, including this tail fluke, looks like no other whale on the planet. It's clear as day a gray whale. And then 22 days later, that same gray whale showed up off the coast of Spain, near Barcelona. So is this a little lost gray whale? That could be. But 2 years later, another gray whale was spotted off the coast of Namibia in the South Atlantic. So now we have two little lost gray whales. What I think this is telling us is that we have to think much more broadly about the history of a lot of these organisms, especially for highly adaptable and migratory species. You know, adaptability, that was a theme in Roland's talk, that's coming out here. So on the right-hand side of this picture, this is a figure from that paper describing the gray whale seen in the Mediterranean in 2012. They've tipped North America on its side to show the possible pathways through an Arctic that are either hugging the coastlines or going a direct route to the Mediterranean. In the case of the whale that was seen off the coast of Israel, that's a 22 to 24,000 kilometer migration. That's nearly the same distance that you would take to go around the whole Earth. So we always knew gray whales were highly migratory, some of the champion migration specialists among mammals. This little gray whale definitely proves that point. But I think what that says is that we have to realize that the future of gray whales is, on this coast, going to look something like this. This is a picture off of California that you could see today, here in April. Off the coast, you see all the houses on the coastline. That's the Monterey Formation in the background, that rock unit. This is the only thing that tells us it's not the East Coast. I think this is what we're looking for in the future, a very flexible, highly adaptive species that will eventually recolonize the East Coast. How soon this will happen? Who knows? But certainly with Arctic sea ice melting predictions being what they are, we're looking at a summer ice-free Arctic potentially in the next 10 to 15 years. Certainly that's a migratory pathway for not just gray whales, but many other species. And I think a lesson we're seeing here is that if we're aware of these ecological surprises, they're actually telling us a lot more about signals, evolutionary signals and ecological signals, than the raw data that we merely get from looking at oceanographic changes through time. And that's it. That's my point. Thanks.
Thank you, Nick. We have time for a couple quick questions. Anybody has one?
So you mentioned that the gray whales took a migratory change from the Atlantic to the Pacific. Would that have anything to do with the environmental changes going on from the Pleistocene to the Holocene?
So the question, if I don't know if everybody heard the question, but so the question is, if they're moving from the Pacific to the Atlantic, does that have anything to do with the environmental changes happening in the last 18,000 years? Yeah, I think it. I mean, previously it didn't. 120,000 years ago, when humans were not on the scene and we weren't active geologic agents, that's changed today. We are changing the biosphere and the geosphere. So that's my answer to that question.
Yeah, I was curious about the disappearance as well from the Atlantic. And is there any evidence of Native Americans hunting them? Because they do stick really close to the coast. So I was wondering if there's any tools or history, oral history, anything about that.
Great question. We need to look more carefully at middens on this coast, I think. That's the answer.
Thanks very much. Suzanne Asha Stone is the co-founder of Wood River Wolf Project and a senior Northwest representative from Defenders of Wildlife. So we're going to switch back again now to predators and wolves. She is an effective and innovative advocate for ranches coexisting with wolves.
Okay, we're going to take a step back a little bit and try to give you a sense of where wolves are. So with that, let's go to our first slide. And we can turn down the lights a little bit. Thank you. Just want you to take a breath away from where you are today and think about where they live. These wolves are coming in a beautiful place where backwoods in Idaho, we have one of the largest contiguous wilderness areas in the lower 48 states. And imagine being a wolf pack in those woods, and the moon is rising, the crickets are chirping, there's birds, there's owls hooting, and you're standing there on land where wolves haven't existed in 80, almost maybe 100 years, because wolves have been driven to complete eradication in the western United States. So as a college intern, that's where I was, standing there looking for wolves in a place where they may or may not be, but we were getting updates from people that were in the backcountry that they thought that they saw tracks, or they thought that they saw heard wolves in the distance. And we would map those and try to go out and find some evidence that wolves were there. And every time, it was just a ghost story. Until one night when I was standing on a bridge, or near a bridge, and there was a river close by. Not the best place to howl because it limits your ability to hear something back. And I howled, and it was a place called the Frank Church Wilderness Area. And nothing. And thought, okay, we struck out again. So I went back to my tent, started putting it up, and suddenly the woods were just filled with this amazing sound. The moon was rising. Right behind them, they started talking to each other, and they howled right to the spot that I had been standing a half hour prior to that. I was stunned. It's not coyotes. It's not dogs. There's no one else around. And they're howling right to the spot that I'd been standing a half an hour before. Finally, I grabbed my tape recorder, and through the tears of frustration of so many years of looking for these animals, here they were. And they howled, and I started howling back to them. Not that I planned on, just that I wanted to. And the deepest male voice, I think, in the pack, and we howled back and forth with each other for what seemed like, I don't know, otherworldly time standing still. And as he would howl and his voice would lower, my howl would come in at the end, and then as I was losing or lowering my howl, finishing it, he would start. And we went back and forth, and it was just magical. To think that these animals were back in a place where they hadn't been for such a long time, that humans had completely wiped them out. Well, a week later, we found one of the female wolves from that pack in Bear Valley. And we wouldn't have found her except for that she'd been poisoned by a neurotoxin that is supposed to treat wheat fields. And there wasn't a wheat field 50 miles away. But the rest of the pack we never heard from again. It was like going back to the, when wolves were eradicated across the western United States. And we knew then that this intentional killing required more protection for them. And so 4 years later, I was to serve on the wolf reintroduction team for Canada and the United States. And we brought wolves back under the full protection of the Endangered Species Act, where they had radio collars and tracking devices that we were able to monitor them all the time and be able to watch where they were going across Idaho and Yellowstone and the Rockies, and see how they went out together and then found each other, created packs. And by that spring, both the wolves in Yellowstone National Park and in Idaho were having pups on the ground. And that was in 1995, 1996, so 20 plus years ago. And now we have 1,500 wolves across the region. And they're not just in Idaho or Montana and Wyoming. They're now spreading to to Oregon and Washington and even California, which I didn't think I'd see in my lifetime, but it's happening. And so this is just an example of how you can bring back a species, even one that is misunderstood and hated as much as wolves, and work with people on the ground. And that's really the next step of what happened, is because even though the wolves were so successful, they still were facing very strong pushback from the people who lived in those communities near where they were at. And in the West, a lot of livestock is raised on national public lands. And so these communities depend on those national public lands in order to raise cattle and to raise sheep. And as soon as wolves started killing cattle again, if they'd been gone for such a long time, this was the reason that they were wiped out to begin with, is people didn't want them threatening their livestock. And so our job then became looking for solutions with the ranchers who were on the ground, trying to help them understand what they could do to protect their livestock better from wolves and even other native predators by using these non-lethal tools, or helping them to avoid having losses in the first place. So this was our challenge, was to meet them out there on the landscape and to talk to them about how we could install fences, or how we might help them keep from attracting wolves by removing carcass pits, which they've been leaving out. And wolves are scavengers as well as predators. So, for us, our brain is set up to interpret smell. It's about the size of a pea. With a wolf's brain, it's about the size of your fist. So they can smell carrion from a very long way away. And helping clean those carcass pits up was a huge step forward in trying to reduce the conflicts that were occurring. But even then, what we were told is that even though it would work on places like this small farm over in eastern Oregon, where there was a huge carcass pit back behind here, probably 200 dead livestock, and the wolves had come in from the mountains back behind, and they had come to this carcass pit, and they made the same decision you and I would make, right? They get to this big dead carcass pit full of slimy, smelling stuff, and then there's spring lambs right here. So their choice was to go for the spring lambs, which I think I would have made that decision too. But what we were being told by the Fish and Wildlife Service and all the wolf scientists that we were working with from around the world is that you can do that kind of thing on a small grazing operation, but you can't do it on a large one. And so we were getting back to the point where, okay, but most livestock and most conflicts with wolves occur on large grazing operations. If we can't use those tools there, really they're not that effective. We're going to go back to this again if we're not careful. And so what we found is that if these livestock are occurring across the landscape like this, that we were going to have to find a way of adapting these tools to work in that big landscape. And we did. We started 10 years ago, And it actually started off as a train wreck. We had the sheep brought in, several thousand sheep brought in to the same meadows where wolves were denning. And they let the sheep out, they dispersed out, and then the wolves were denning right back over there. And of course, within a day, wolves had heard the livestock guardian dogs, which they know are strange-looking wolves, and strange-looking wolves are the biggest threat to their pups. And so they came out at night with the dogs barking, they killed a dog, they killed a bunch of sheep, and in normal conditions, that meant that that pack had a death sentence, that they wouldn't survive because the government would come in and kill those wolves. But what had happened is the local community had fallen in love with these wolves. They had watched them raise their pups at this den site, they had given them a name, and they didn't want the wolves killed, so they asked them for a second chance. And we were able to give that by going out and teaching the ranchers about things like fladry, which had come from Poland. Originally, it was used to help hunters kill wolves, but we adapted it to be a livestock protection device. And so wolves were denning in that meadow right there, and they were denning there for over a month, with the sheep being there in the valley, and we didn't have any more losses, no more conflicts. And for the rest of that grazing season, that worked. And we started monitoring wolves and determining where they were and what packs we were working with that were there in that project area. And we started off at about 100 square miles, and we're at 1,000 square miles right now, and covering far more land than we thought we would. We have between 10 and 22,000 sheep in our project area every year from June through mid-October. And what we're learning through all of this is that, yeah, wolves can coexist with livestock across big open ranges, as mountainous as they are, if you use the right approach, if you're working on solutions, trying to keep wolves' sense of risk elevated near the livestock so that they stay onto their natural prey and focus on that rather than focusing on the livestock itself. And it really isn't that hard. We've come up with a lot of different devices, some of which are kind of new technology, but like using livestock guardian dogs. We know that we don't want to use them in the spring when it's close to a wolf's den because they will get very defensive and attack the dogs. But if you use them any other time of year and you use multiple dogs, then you're going to be okay because they think that's a strange pack and they don't want to mess with the strange pack. So these devices have been really helpful for us. And they've been really helpful for the sheep because in the last 10 years, out of all those thousands and thousands of sheep that are out there, we've lost 30 completely, about 3 a year, which is the lowest loss rate of sheep on public lands in wolf range in the western United States. And wolves kill more sheep than they do anything else. So we took the hardest case scenario and we made it work. And if we can make it work there, we can make it work anywhere. So we have wolves across the range. Not a single wolf in our project area has been killed because of conflicts, which if you go right next to us in the adjacent project area, they've killed packs of wolves over there, and they've spent more money than we have killing wolves, and they're not using the non-lethal like we are. So it's more expensive for them. They're losing more livestock, and they're killing wolves, which disrupts the whole system. We come from a community where people really care about their natural heritage, but they also care about their agricultural heritage. We actually have a parade every year and bring the sheep right down the middle of downtown. So we got bagpipers out there. The priest comes out and blesses all the sheep. People love them, and that's great. But they can coexist with wolves, and they love the wolves too. And that's a pretty unique part of our community. These are some of the guys that I work with. I wish they were here. Commissioner Schoen, Brian Bean, who's the sheep manager, some of our one of our herders, and then a scientist from University of Spain. And we've been bringing people out to the field. We do trainings every year for folks that are now being presented in other areas where they're developing models like this Wood River Wolf Project. I just heard from folks in Estonia a few days ago. It's just going everywhere. And we're able to communicate and network and share these devices with them and these strategies, and then learn from them as well, which is what we've been doing all along. Thank you.
Time for one question for Suzanne before we go on to the last talk.
Hello, thank you so much for being here today and speaking. I was wondering if you could speak on the state of legislation in this country. I know there's been some recent ones on hunting of wolves and what needs to change moving forward.
That's a big question. So you're asking about legislation with wolves, and that's different in different parts of the country. Uh, so in places like Oregon, Washington, wolves are just coming back in those states, and there's quite a bit of protection still for them in those areas. But in places like Idaho and Wyoming, unfortunately tomorrow, Wyoming is the day when we lose protection for wolves across more than almost 90% of the state. And so there's a lot of work left to be done on the more political end of that spectrum. There's not a lot of trust yet in these non-lethal methods. And the more that we can get this information out, we just published a paper in the journal Mammalogy this last month, and it addresses these concerns about, or at least the pushback that we got originally, that these non-lethal things can't work on these big landscapes. They can. They can work with cattle. They can work with sheep. They can work everywhere that we have wolves across the western United States and other places, and they work with other predators too. So we just really need to change the whole paradigm of how we're managing predators. That's easy. We'll do it. Thank you.
Thanks very much. Our fifth and last speaker in this session is Jeff Hall. He's a forest ecologist at the Smithsonian Tropical Research Institute, and he's the leader of the project called the Agua Salud in Panama, which involves restoration of forests back into an important watershed with important implications for wildlife and humans.
Thank you, Doc. So I'm going to just start with a disclaimer. I'm not going to show you a single image of a warm, fuzzy mammal, predator or otherwise. In fact, I'm not going to show you a single image at all. I live in Panama, and so I'd like to, in your minds, just take you all to Panama with me. And right now, it's the end of the dry season, and so it's hot. It's been really hot, and it's been really bright. But instead of it being bright and sunny, I'd like you to imagine that the skies are black, that it's just raining buckets and buckets and buckets of water. The storm has been going on for a week, and it's the end of the rainy season, and the rivers are swollen with water. And they're so swollen that they're almost overcoming the bridges, and the city streets are flooded. Well, that exact same thing happened starting December 7th in 2010. At the end of what was already on track to be one of the wettest years on record, we had the flood of record in the Panama Canal watershed. There was so much water that the Panama Canal Authority had to close the canal for shipping. They had to open up all the floodgates and the locks and evacuate as much water as fast, efficiently, and safely as possible. Now, this is a big deal. This is the first time they've done anything like this in some 70 years for an environmental reason. So Madden Dam is on the Chagres River, and above Madden Dam is a lake called Alajuela Lake, and Alajuela Lake is where we store the water for the dry season. And above that is Chagres National Park, a completely forested national park. Well, Madden Dam was at the specifications of what it was built to withstand. So we have a research project in the Panama Canal watershed, and it's called the Agua Salud Project. And among other things, we measure stream flow under different land uses. And at our project site, we have the same soils and geology as the whole upper Chagres watershed, so that forested national park. And so that allows us to do some kind of quick and dirty, if you will, or easy extrapolations. So now let's imagine that we deforest Chagres National Park, and let's apply the excess water that we had in our pastures compared to our forests to that area. If we do that, we would have had 100 million cubic meters of water arriving at Madden Dam right when it was at risk of breaching. A cubic meter weighs a metric ton. An elephant weighs a metric ton. So we're talking about 100 million elephants full of water, if you will, hitting that dam right when it was most vulnerable. So we believe that the forest helped save the dam. The forest helped save, really, the canal. And so, well, why should we care about that here in the United States? Well, whether you realize or not, of all the goods that come to the East Coast for the United States from Asia, 40% of those goods come through the Panama Canal. So it has important implications for the United States, but for Panama, were it not for the forest, we would not have this past year celebrated the expansion of the canal and the opening of a new set of locks, but we would be rebuilding the canal and we'd be rebuilding the economy of Panama. So La Purísima is the name of our storm. And so for us, that was our Superstorm Sandy or our Hurricane Katrina. And one of the predictions or that scientists have great confidence in climate change is it will have more frequent severe weather events. And that the past is not a good prediction of the future. Well, people say that La Purísima was somewhere between a 100 and 300-year event. And so all of us in the room, I'm sure we know that that doesn't mean that we're good for another 200 years, right? But it does mean that it's rare. It means that it's very rare. Well, less than 2 years after that, 2012, we had another big storm, and we had loss of life in the Panama Canal watershed, and we had roads washed out. And just last year, we had another big storm in the Panama Canal watershed. In the last 6 years, we've had the 3 largest storms of the last 50 years in the Panama Canal watershed. The protection that forests provide from these large storms, that's something that we call ecosystem service, and I'm sure you're all aware of ecosystem services. And there's a whole suite of goods and services that we as humanity, that we get from nature that we often take for granted. And another forest and water-related ecosystem service in the seasonal tropical forest area is the idea of a sponge effect. And that's the idea that where there are these forests that they can absorb water in the wet season and then release it slowly in the dry season. And this has been controversial, but we have consistently shown this at our site. So we don't just study water flows, but we also do a lot of restoration, a lot of reforestation, and we plant trees. And one of the things that we're studying is the idea, can we reestablish, can we restore this sponge effect? And we've shown consistently that by planting trees, we can, in a reasonable time frame, restore the ability of the soil to absorb water. And that is the critical mechanism for the forest sponge, to allow it to absorb the water, and that's the critical mechanism for shunting water away from the overland flow that would go into the rivers that would lead to these big floods. So let's shift and talk about trees. And one tree species, tropical hardwood, that you're probably or may be familiar with is teak. And teak is native to Asia, but it's planted all over the world. And teak is used for furniture, it's used for veneer, and it's used in boat building for boat decks. But one that you might not realize or might not know about is one that I want to show you now. This is my show and tell, is cocobolo. And cocobolo is a craftwood that's native to Panama and adjacent countries, Dalbergia retusa. So I hope that you'll remember cocobolo at the end of this talk. On September 23rd in 2014, less than 3 months after having been sworn in as president of Panama, Juan Carlos Varela went to the United Nations Climate Summit, and he announced to the world his intention to reforest 1 million hectares in the country of Panama. And this was part of his effort, his country's efforts to combat climate change. And through this Alliance pour el Million, as it's known locally, he was explicitly acknowledging that planting trees in the tropics is one way to adapt to and mitigate the effects of climate change. A hectare is about, what, 2 football fields, a little bit more than 2 football fields. So we're talking about 2 million plus football fields worth of reforestation. This is pretty ambitious for any country, certainly for Panama. So the question is, how do we do it? Well, another story. In 2003, researchers published a paper where they included a carbon baseline for the Panama Canal watershed. So what they did is they used remote sensing. They figured out where all the vegetation is, and they figured out how much carbon's there. And so we have this baseline, and it's important so that we can evaluate future activities at reforestation to know if there's some net positive benefit in carbon sequestration or revegetation. And as part of that scenario, part of that paper, they had different scenarios for the year 2020. And all of the 2020 scenarios had the eastern Panama Canal watershed reforested by the year 2020. And this made sense. This made sense because there were all kinds of incentives for reforestation then. You could get a tax break, and one of my favorites is the reforestation visa. So 75% of what's been planted in Panama traditionally has been teak. And so you might think that these researchers would have thought that by 2020, that the watershed, the eastern watershed, would be reforested in teak, and that's exactly what they thought. But it's 2017, so if this was going to happen, we should be able to go out that area and we should see trees and teak everywhere. But you don't. Instead, you see a mosaic of agriculture and urbanization. So what happened? Well, it turns out that teak needs relatively fertile soils. Teak needs soils with a good loamy soils, as we call them, so a good mix of sand, silt, and clay, and teak does not grow particularly well on acidic soils. And it turns out that these soils are pretty rare in the lowland tropics, and they're really rare in the Panama Canal watershed. So we've conducted an economic analysis. We published a paper to show that just deforesting and putting the cows up on the back 40 in the backland and managing a degraded pasture, that makes more money, or as I often say, it loses less money than teak in the Panama Canal watershed. So when it costs $5,000 to reforest and manage for the first year or so, and if you have 100 hectares and it doesn't grow well or it all dies, that's $500,000 that you have at risk. Well, imagine if you had 1,000 hectares. Or imagine if you had President Varela's 1,000,000 hectares. So, okay, what do we do? Well, let's use native species. Why not? I mean, they're found in the country. They should grow well, right? Well, of course, I'm sure you realize it's not that easy, right? Just because something's native to a country doesn't mean it grows well everywhere, right? There are logistical challenges of figuring out how to germinate the seeds, how to manage the seeds and seedlings in the nursery, and how to get them out at the right time, at scale, to the places you want to reforest. So we ourselves and others around the world, we've done research learning about how to manage the seeds and seedlings in the nursery. We published our own guidebooks on how to manage 120 native species in a nursery, and where 64 native species grow well or not under different soil fertility and rainfall conditions. So this is a start. And as part of our research, yes, we have found some native species, some timber species that grow well. They grow really well on these infertile and acidic soils. And so now we go back to cocobolo. So cocobolo is a valuable craftwood in Panama. And so how valuable is it? Well, I heard somebody ask that there. The best teak in Panama is worth about $600 a cubic meter. Cocobolo is reportedly worth $10,000 a cubic meter. So there's, it's so valuable that there's an illegal trade in cocobolo, right? And believe it or not, the cocobolo trade in Panama has been equated with the drug trade. And if you find that hard to believe, I don't blame you. But the fact is that cocobolo have been poached from forests and farms, that government vehicles have been vandalized because of enforcement activities, and that there have been whole containers of cocobolo that have been seized at the ports on their way to Asia that are marked scrap metal. So in our own research on reforestation, we've seen that cocobolo grows pretty well on these acidic or these poor soils. That's great. We only have about 7-8 years worth of growth, and so we've gone out and measured other stands. There's at least one stand where people have planted cocobolo that's 20 years old. And that stand, having measured it and estimated, that is worth over $200,000 a cubic meter if these reports are correct about the value. So imagine what $200,000 could mean to a rural landowner. But let's say I'm wrong. Let's say it's not worth $200,000. Let's say it's only worth a quarter of that. If a rural farmer could make $50,000 a hectare, so for 2 football fields worth of land, in 20 to 30 years, that could make a huge, huge impact on his or her life. So we have challenges in this world, right? And sometimes they seem enormous and insurmountable. But we can use science, and that's what this conference is about. We can use science to overcome these challenges. And the story that I've just told about teak and about cocobolo and native species, for me, that's a hopeful story about how we can use science to understand about forestry so that we can plant the right trees in the right place at the right time and for the right reason. The story that I told about La Purísima, our superstorm, there are different perspectives on that. And you know, first and foremost, we have to acknowledge the incredible professionalism that the Panama Canal Authority had when they managed that storm to avoid catastrophic loss of life and livelihood. But there's another perspective, and our perspective is about the science. If we hadn't been doing the science, we wouldn't know the extent to which the forest helped save the day, the extent to which that forested national park helped really protect the whole economy of Panama. So today is Earth Day, and I think I'm the first person to mention that in this little talk. And but you didn't know that, did you? I have 2 boys, and my 2 boys are in Panama City, and they're out on beach cleanup. And that's very similar to what I would have been doing when I was their age, and what I'd probably be doing if I wasn't here. Today there are hundreds of thousands, and we hope that there's many millions of people who are outside doing something good for the earth. And we know that some people are on beach cleanup, some people are protecting wolves, I'm sure, right? Some people are recycling, some people are marching, right? And some people are planting trees. Our research, the research that's being talked about throughout this whole conference, it shows the power of science in helping to guide these efforts so that we're effective and so that they're efficient. And when we combine our science with citizens' great intentions, we can build that sustainable future that we all want and that we all need. Thank you. And this is for sale? I can know.
Yeah, it's only $11,000. Thanks, Jeff, very much. First, a couple of quick announcements on timing, and then we'll see if we can answer a few questions. Because of the shift in scheduling this morning from the plenary session, I've been asked to let you know that learning lunches are shifted to 1 to 2 o'clock. That's in 15 minutes. And the plenary session this afternoon, which was scheduled at 2 o'clock, will start at 2:15. So you might make a note of that. Well, I want to thank all 5 of our speakers for very interesting and very inspiring talks today. Thank you very much. And especially for all staying on time. That was great. So I'm happy to have the group talk and for 2 or 3 minutes here and ask a couple of questions if there are some. We have enough flexibility for that. Anybody have a pressing question? Matt, use...
A wolf question. Do I need the mic?
Yeah, you need to use the mic.
You gave us a lot of information, but I was hoping for a little more detail. So you showed us the red flagging on the fence. How do the wolves not like flagging? Or what's the story behind the mitigation of the wolf attacks?
This is called fladry. And in Poland, generations ago, what would happen is the villagers would supply old rags, old clothing that they would cut up, and they would put it on rope, and they would do these long ropes with these clothing pieces hanging from them through the woods, and they would set it up in a V. And at the wide end of the V, they would do what I did to try to keep wolves out of sheep camp a few years ago, where I took a wooden pot and a pot and a wooden spoon and chased wolves away from the sheep. They were chasing wolves into the wide end of this V, and then the hunters would wait for them in the narrow end in the funnel, and they would kill wolves. And so one of my professors brought this from Poland to the University of Calgary and tested it with captive wolves, and then we tested it out with wild wolves in Idaho. Around about 9 miles of a ranch there, wolves had been denning, and then they usually would come back with their pups after they went to rendezvous and come back to this ranch and kill cattle. And wolves don't like this stuff. And if you go, actually Google, Washington Department of Fish and Wildlife has a video online that shows you a wolf coming back, I think it's 17 times to the same cow carcass. He jumps over the barbed wire like it's not even there. But with this stuff, he was so afraid of it that he never penetrated the fladry. I was going to show you the picture that I have of it here. And so it's a great non-lethal tool. We don't know why it works. We just know that it does work. And we have used it around sheep camp We haven't actually used it in about 4 or 5 years. We have so many other deterrents. One of the most important things with working with predators is to keep developing or changing up the types of deterrents that you're using so they don't become habituated to any one particular tool. But this tool works great if you're in a kind of ground zero type level where you know you've got wolves that are denning like really close to where the livestock are. And we used it out there for 63 days without wolves penetrating the flattery. They tend to really avoid it. But you've got to make sure you keep changing things up, because if you show them the same deterrent over and over again, like the fox lights we have as well, eventually they'll lose their fear of them. And so we don't do that. We change things all the time. But you're welcome to come talk to me about the flattery. And if you want a piece, you're welcome to it.
One more question before we break up. I'm sure the individual speakers would be happy to talk with you. We're over time? Okay, we're 3 minutes, 3 minutes over time for us. Okay, you can talk outside then. Thank you.